Hi guys, I am going to go over the first few questions of Chapter 7 now. In Chapter 7, we're talking about periodic trends and about how the nucleus, the protons and the electrons in the nucleus react with each other, so that way whether or not the electrons are getting pulled in or they're getting more spread out, things along those lines, and how that changes on the periodic table. All right, so among elements 1 through 18, so that's a lot of elements there, which element or elements have the smallest effective nuclear charge? Well, when I originally did this, I went through all 18 elements. For instance, hydrogen, it has 1 electron, so it's 1s1. Helium is 1s2. Then lithium is 1s2, 2s1. And I kept going on and on and on. So from here, we can then look at the Z effective by saying that Z effective is equal to the number of protons. So the Z is the protons minus the S, which is the electrons that are in the central or the core electrons. So for instance, if I'm looking at lithium, we have 3 protons in the middle. We have the first shell, which has 1s2. Then we have the second shell, which is 2s1. That 1s2 here, that's going to be your S. Those are the shielding electrons. That's why it's an S, is because S stands for shielding. So that means the Z effective here is equal to 3 for those protons minus these 2 electrons here, which are shielding. If they're in the same orbital, they're not going to be shielding. So for instance, with helium, Z effective would be those 2 protons minus 0, because both of those electrons are in the same orbital. So with the Z effective for helium is going to be 2, whereas lithium is only going to be 1. We can move on to boron. We can take a look at that one. Boron is 1s2, 2s2, 2p1. Both of these are in the same shell, so they're not part of the shielding. The only one that's shielding is that 1s2. So that means Z effective. Boron has 5 protons minus these 2 from the first energy level. So it has a Z effective of 3. Again, the 2s2 and 2p1 don't count towards it. We can continue. And as we're doing this, you'll notice that there is a trend. So let's jump to nitrogen maybe. That has 5 electrons, 1s2, 2s2, 2p3. So Z effective is those 7 protons minus just these 2. So that means the Z effective is 5. Notice once again, I did not encounter those. So you'll notice that the Z effective, you'll see that it's actually starting to be like their valence electrons. So in this particular system, the valence electrons are going to determine what the Z effective is. If I move down to, let's try sodium. Sodium is 11. 1s2, 2s2, 2p6, 3s1. So 3s1 is our valence electrons here. All of this is our core, which means those are shielding. So that means sodium is 11 for the protons minus those 10 for our core electrons, which give us 1, which is actually also the number of valence electrons they have. So if we go through this, we can make those comparisons. So if we are looking for the smallest, that means we're looking for the ones with the valence electron of just 1. So that means the ones with valence electrons of 1 would be hydrogen, lithium, and sodium. All of those are the smallest because they all have a Z effective equal to 1. If we're looking at the largest, we're looking at the 8 electrons. So again, we're looking for the largest here, the largest Z effective. So we're trying to figure out which of these we're subtracting the least amount from. So you notice that nitrogen was 5. And then that means that if we did oxygen would be 6. Then we'd have fluorine. And then all the way up to neon. And once you get to neon, you're looking at 8. Because if we're looking at the electron configurations, neon has 10 electrons, so that's 1s2, 2s2, 2p6. So originally it had 10 protons. These two here, these 2 electrons are shielding, so that gives us 8. These are not shielding because they're all in the same energy. Even though there's a full octet, it's still considered to be part of the same energy level. I'm going to stop here because the bell's going to ring again. I just didn't want to re-record. Hopefully you're understanding this, that the Z effective, the way that they're having you chart to look at it, you're really just looking at the valence electrons. And this was question number 13.